Welcome to the third section of this course. In this section, we will study ways to better organize our code in modules. In this section, we will begin with the reasons why we need modules in our JavaScript code. We will then study the origins of all module loaders. We will move on to studying the Node Package Manager and a few common module standardizations, including CommonJS, AMD, and the latest ES6 modules. Finally, we will examine tree shaking and how that can help us clear up the result of our code. In this video, we will study the reasons why you might want to split your JavaScript code into modules. There are many module loaders or bundlers out there. You keep hearing about Webpack and CommonJS and the shiny new ES6 modules, but why did we come to have so many module definitions? You will learn why in this video. So this video will teach you two things. First, why we need to split our code into modules, and second, why we came to have so many module definitions in the JavaScript world. The most important reason why we need modules is to easily organize our code base. You wouldn't write a Java or C# application in one file, so why do that with JavaScript? Every non-trivial application needs to be split into different files. The next reason is namespaces. JavaScript does not have the notion of namespacing built in, like C++ does, for example. So we need a way to introduce that logic into our code. Otherwise, every time that we define a new variable, we would have to be careful not to cause any conflicts. And finally, we have dependencies. JavaScript applications have evolved. Times when you just used to bring in jQuery from CDN and write a 20-line code file to perform a few animations are now long gone. Nowadays, JavaScript applications have huge dependency trees. Just take a look at the dependency tree of an Angular or React application. It simply is impossible to have to figure out the dependencies on your own. Let's demonstrate these 3 points in this example. We have a file called app.js that contains the definitions of 3 classes. Each class has a method called doThing. That method prints the name of the class followed by the name of the method to the console window. Under each class definition, we instantiate a variable of that type and execute the doThing method. And if we visit the index.html file, we see that we include the app.js file using a script tag, the traditional way. No module loaders, nothing fancy. If we switch over to the browser, you can see that we indeed get the desired output. The 3 classes execute the doThing method in succession. Now, let's say that we want to follow the first point that we discussed earlier, that of code organization, and split our code into different files. We will have an a.js file containing class A. Then we will take the definition and usage of class B and put it in a separate file called b.js. Let's paste it. And we are going to do the same for class C. Therefore, we will create a c.js file. We will copy the contents from the app.js file and paste them in c.js. So now, in order to run the application and get the same result, we will need to remove this script tag and replace it with the inclusion of the 3 files, a.js, b.js, and c.js. If we go back to the browser and refresh, you see that we get the same output. But there's a catch. What if one of our classes has a dependency? So let's say that we visit a.js and add an implementation for its constructor. Now the constructor needs to have an instance of class B. So now A depends on B. The doThing method will also call the doThing method of the B instance. That means that when we instantiate class A, we need to provide an instance of class B. If we refresh the browser, we get an error, and that's perfectly normal, because by the time that a.js is included in our code, JavaScript doesn't know what B is, which means we need to take the definition of B and put it above A. This is the dependency tree I was talking about. Now take a look at this output. We have B do thing executed first because we included b.js before a.js, and then we have B do thing executed again because it is executed by a do thing. Imagine having to know the dependency order of all libraries and frameworks in use by, say, Angular or React. It will be impossible. Now that you know, if you didn't already know of course, why we need modules, you may be wondering, why do we need so many module definitions, loaders and bundlers? Why CommonJS, AMD, UMD, System.js, Webpack, Browserify and all that? Well, the answer is that because JavaScript does not offer a built-in mechanism for handling modules, developers had to come up with ways, and thus all those definitions were born, each solving a different part of the problem. We will study them in length in the next videos.